So hi guys, today in this video we are going to look at another question. The question is constant time range add operation in an array. So we have been given an array A of size n and q queries. The array A is initialized by 0. All the elements of the array are set by 0 initially. We have to apply these queries and we have to give the final result of the array. So each query is of the type Q, S, E, and val, where S is the start index of the range, E is the end index of the range, and val is the value that we have to add in the range start to end. So let's take an example. Like we have been given this array and we have been these queries. This is query Q1, Q2, Q3, Q4. So in this query we have been given a range 1 to 3 and we have to add value 1. So let's pick the range 1 to 3. We have to add 1 in this range. Second query is from 2 to 5. We have to add 6. So this is the index 2. Starting from index 2, we have add 6 until 5. And 0 to 3, we have to add 2. 0 to 3, we have to add 2. And 4 to 6, we have to add 3. 4 to 6, we have to add 3. This is plus 3, plus 3, and plus 3. The final value at this position will be 2, and at index 1 it will be 1 plus 6 plus 2, that is 9, and so on. We can calculate all the values, final values. So what will be the time complexity if we try this approach? That we start with each range and add the value and do this for n number of different queries. For each query we have to iterate between the start index to the end index. Start to end we have to go, and this will be of the order of n because this range at maximum can be n, and we have to add the value. So if we do this for n number of queries, not n, but we do this to q number of queries, then the time complexity becomes q times n. So as we can see what we have done in this array, we have added elements in a range. So it's like propagating this one. So as we add 1 at this index 1, we are propagating it until 3, and as we add 6 here, we are propagating it until index 5. So we are propagating the same value in a range. And as we know in the prefix sum, we actually propagate value from the from particular index to the end of the array. Like so, let's take an example. If the value, if I put 2 at index 1 and I calculate prefix sum of this array, then it will be 2, 2, 2. So actually I'm propagating this value until the end of the array. And if I uh, put 3 at index 2 and calculate the prefix sum, then what I will be doing? So if I calculate the prefix sum at this will be 2 at this position it will be 2 plus 3. So it will become 2 plus 3. Here it will become plus 3 plus 3. So basically I am propagating this value until the end of the array. So there is a similarity between these two. So the only difference is here we are propagating a value until the end of the array, and here we are propagating a value to some range. If I only want to add 2 in the range 1 to 5, so what I can do, if I calculate the prefix sum with this value, I will get 2 2 2 2, but I want to keep my 2 in the range 1 to 5. So what I can do, I can add minus of this value, that is minus of 2 at 6. So so as soon as I calculate the prefix sum here, these two will negate, and this will become 0, this will become 0. So this is the trick. Suppose this is start index, this is the end index, this is the query start and end, this is the value to be added. So I have to add, if I add this value to here and at index e plus 1, if I add value minus of and when I will calculate the prefix sum of this array, this value is going to propagate, this value is going to be this value is going to propagate until here, and here this will negate, this will be 0 because and minus will cancel each other. So better way to solve this problem is we can gain an array like this. So rather than adding all the elements in the range, we will just put this element in the starting index of the range. So we'll put 1 here, and 2 to 5, but at index 3 plus 1 we'll put negative of this value. 3 plus 1 is 4, we'll put minus 1 here. At index 2 we'll put 6, and then at index 5 plus 1, that is index 6, we'll put minus of this value. At index 0 we'll put 2, at index 3 we'll put not 3 plus 1, that is index 4, we'll put minus of 2. We will have to add minus of 2 here. Minus 1 minus 2 will become minus of 3. So let's add minus of 3 here. At index 4 we will put 3, and at index 6 plus 1, 6 plus 1 is 7, we will put minus of 3. We'll put minus of 3 here. So at index 4, minus 3 and 3 will cancel out to be 0. So the final value here becomes 0. And finally, we'll calculate prefix sum over this array. So prefix sum here becomes 2, 3, 9. This is again 9. This is again 9. This is 9. This is 9 minus 6, 3. This is 0. So this will be the final state of the array. And the time complexity of this solution. So see, for each query we are just adding elements at 2 locations only, that gives a factor of 2, and we are doing this for q number of queries. So for queue number 3, we are just adding elements at two locations, that is start index and the end index. And finally, what we are doing, finally we are calculating prefix sum over this array, which will be order of n time. So the overall time complexity becomes order of q plus n. So which is a linear time solution. Thanks for watching. See you in the next video.